Good afternoon, Doc. Good afternoon, classmates. I am Alvi Basanyas, and we are the Group 2. This is the continuation of our report in Chapter 2. So, the last reporter should discuss about the steps of performance assessment of process and product. So, it has 5 steps. So, the last steps of that is to choose the appropriate statistical tool. So, why do you think we need to choose an appropriate statistical tool? We need to choose an appropriate statistical tool so that our results and interpretations are all valid and exact. For instance, the project is about the investigations of the utilizations of milkfish bones into polvoron. So now we came up into 2 research problems. First problem is, what is the general acceptability of the quality attributes of polvoron with and without milkfish bones? The second is, there's a significant difference on the general acceptability of the quality attributes of the polvoron with and without milkfish bones. So that's are the 2 specific problem or research problem that we're going to look for an appropriate statistical tool so that we can have the results that we need, which is valid and exact. So now the first research problem will be discussed by Miss Balungan, and I'm going to discuss to you the second problem. So now let's discuss the appropriate statistical tool of specific problem 2, which states, is there's a significant difference on the general acceptability of the quality attributes of polvoron with and without milkfish bones. So as you can see on the problem, it already states the significance difference. So it has also 2 variable, which is the milkfish bones, polvoron with milkfish bones and polvoron without milkfish bones. So now we're going to use a t-test paired 2 sample for means. So before we go to the computation process, let me discuss to you first what is t-test. So that is why you can have any idea why we need to use this kind of a statistical tool in this specific problem. So now let's discuss what is a t-test. A t-test, it is a type of inferential statistics used to determine if there is a significant difference between the means of 2 groups which may be related in a certain feature. So when we say inferential statistics, it allows you, or it allows us to make predictions or inferences that we from the data that we have gathered. So a t-test look at the t-statistic, the t-distribution, and the degrees of freedom to determine if there is a statistical significance. Essentially, the t-test, it allows us to compare the average values of the 2 datasets and determine if they came from the same population. The outcome of the t-test, it produces a t-value. So this t-value is this is the result of the t-test that we're going to do later, or we're going to compute later. So that's the result of that is it calls t-value. So this computed t-value is now compared against a value of 10 from a critical value table, or the t-distribution table. So this is the t-distribution table, or it is also called as t-table. So later we're going to use this so to have our t-critical value. So I'm going to show you on how to use this t-table. So to obtain the value from the critical value, we need to solve first our degrees of freedom, and after having our degrees of freedom, we can now use our t-distribution table with also having our t-critical, or the probability value. So we're going to use the degrees of freedom and also the t-critical, or the probability value, so that we can use our t-table, or the t-distribution table. Go back to our problem. So our problem is that there is a significant difference of the general acceptability of the quality attributes of pulveron with and without milkfish bones. So therefore, we use that t-test therefore we use t-test per two sample for means. So when we say per t-tests are typically used to test the means of populations before and after some treatment. So for example of this is the two samples of math scores of the students before and after the lesson. So why t-test per two sample for means? Because the panelists evaluated the paired product of a variable 1, which is pulveron with milkfish bones, and variable 2, which is pulveron without milkfish bones. So this is the formula of t-test. So t-test equals summations of d is the difference, divided by square root of n, which is n is the number of cases, times summation of d squared minus summation of d squared divided by n minus 1. So now, summation of d or difference, it is the sum of the variable 1 and variable 2. And then the summation of d squared, it is the sum of the squared difference. And the n here is the number of cases. So to substitute formula 2.2, we need to follow first this step so that we can have all the value that we need in solving the t-test. So now the first step, or step 1, is to look for the difference between variable 1 and variable 2 and write it under the d column. And then step 2, we need to sum the d column to get the summations of d. And then step 3 is that multiply d column by itself to get the d squared. And then step 4 is that sum the d squared column to get the summation of d squared. And then after that, the last step is that we can now apply the formula 2.2. So first, let's look at this table here. So we have here a 5 column. So the first column is for the panelists. So because we have 15 panelists, that is why I write down here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 panelists. So that is why it's all 15. So now we on the second and the third column, that's our variable. So we have two variable. So the pulveron with milkfish bones and the pulveron without milkfish bones. So the second column, it is the pulveron without pulveron with milkfish bones. So maybe you're wondering how did we get these numbers? Where did it came from? So there are out of 15 panelists, there are 1, 2, 3, 4, and 5 panelists who evaluated the pulveron with milkfish bones, and they gave a score of 9. So that is why we have here that number. So now there are 1, 2, 3, 4, 5, 6, 7, and 8 panelists who give a score of 8 in pulveron with the milkfish bones. So now there is 2 panelists who give a score of 7 to the pulveron with milkfish bones. So now let's go to the third column. So the third column, it is also the scores that have given by the evaluator, which is the panelist. So there is one panelist or a panelist who give a score of 8 with a pulveron without milkfish bones. So now there are 1, 2, 3, and 4. So there are 4 panelists who give a score of 7 with a pulveron without a milkfish bone. So now let's go to next is that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there are 10 panelists who evaluated the pulveron without milkfish bones, and they only give a score of 6. So now that we have all the value from variable 1 and variable 2, so now let's get the difference of each variable. So what are we going to do? We need to subtract the variable 2 from variable 1. So now let us subtract variable 2 from variable 1, which is 9 minus 8 is equals 1. 9 minus 7 is equals 2. 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 8 minus 6 is equals 2. 8 minus 6 is equals 2. 8 minus 6 is equals to 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 8 minus 6 is equals to, and 7 minus 6 is equals 1. 7 minus 6 is equals 1. So therefore we have now all our difference in the D column. So what are we going to do next? So according to the step, we need to get the sum of the D column so that we can have our summations of D. So now let's add all this together. The column D, let's add all together. So 1 plus 2 is equals 3, plus 2 is equals 5, plus 2 is equals 7, plus 2 is equals 9, plus 2 is equals 11, plus 2 is equals 13, plus 2 is equals 15, plus 2 is equals 17, plus 2 is equals 19, plus 2 is equals 21, plus 2 is equals 23, plus 2 is equals 25, and plus 1 is equals 26, plus 1 is equals 27. So therefore, we have the summations of D here of 27. So now, after we have added this all together, what is the next step that we're going to do? So according to the step, we need to multiply the D column by itself. So therefore, we need to multiply each number or each difference here by itself. So 1 times 1 is equals 1. 2 times 2 is equals 4. 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 2 times 2 equals 4. And 1 times 1 equals 1. 1 times 1 equals 1. So therefore, we have now our difference in D square. So now, after that, what is the next step that we're going to do? So according to the steps, we need to sum or add all together the D square column to have the sum, to get the sum of the summation of D squared. So now let's add all together. So 1 plus 4 is equals 5, plus 4 is equals 9, 9 plus 4 is equals 13, 13 plus 4 is equals 17, 17 plus 4 is equals 21, 21 plus 4 is equal to 25, 25 plus 4 is equals 29, and 29 plus 4 is equals 33, and 33 plus 4 is equals 37, and 37 plus 4 equals 41, 41 plus 4 is equals 45, 45 plus 4 equals 49, 49 plus 41 plus 1 is equals 50, and 50 plus 1 is equals 51. So therefore, our summation of D squared is 51. So now that we have all our value, So now let's substitute this formula. So T-test is equal summations of D divided by square root of n times summation of D squared minus summation of D squared divided by n minus 1. Divided by n minus 1. Summation of D is the 27. So let's put 27. And then n is the number of cases. So we put here 15. And then summation of D squared is 51. So we put down 51. And then minus summation of D. So the summation of D here is 27. So we put here 27. And now 27 and 27 squared, and then divided by n minus 1. So the n here is the number of cases. So let's put 15 minus 1. So now let us solve. So first we're going to solve the square root of n times summation of D squared minus summation of D squared. So 15 times 51 is equal 765. So we put 765 here, and then minus 27 square. So let's look, or let's get the square root of 27. So you can use your calculator or cell phones on getting the square root of 27. So the square root of 27 is 729. So that is why we put here 729. And then let's so now let us subtract 1 to the number of cases, which is 15. So 15 minus 1 is equals 14. We have now 27 divided by square root of 765 minus 729 divided by 14. So first we need to solve the square root of 765 minus 729 divided by 14. So 765 minus 729 is equals 36. So that is why we put 36 here. So now we have 27 divided by square root of 36 divided by 14. So the first thing that we need to solve here is the square root of 36 divided by 14. So 36 divided by 14 is equals 2.57142857. So that is why we put 2.57142857 here. Now we have 27 divided by square root of 2.57142857. So now the next thing that we're going to do is we need to get first or solve first the square root of 2.57142857. So again, we can use calculator here or our cell phone to get the square root. So the square root of 2.57142857 is 1.60356745. So now we have 27 divided by 1.60356745. So let's divide. 27 divided by 1.60356745 is equals 16.837. So that is why our t-test or t-value is 16.837, which is significant at 0.01. So now we're going to determine how it became significant. So later I'm going to explain it. And so now let's go to let's get the degrees of freedom. So the computations of degrees of freedom is this is the formula of the degrees of freedom. So df equals n minus 1. So df is the degrees of freedom. So n is the number of cases. So because we have the 15 panelists, so let's put 15 minus 1. So 15 minus 1 is equals to 14. So therefore we have our degrees of freedom is 14. Now that we have our degrees of freedom, which is a 14, so we can now compare it with the t critical. So our t critical here is 0.01. So on comparing the degrees of freedom with the t critical or t tabular, we're going to use the t distribution. So as you remember earlier, I show you the pictures of how does it look, the t distribution, or the t distribution table, or the t table here. So it is the t distribution table. So now the degrees of freedom, our degrees of freedom is 14. Where is the degrees of freedom here? So the degrees of freedom here is in this side. So this is the degrees of freedom. T critical, or the probability value, is the 0.01. So we can look, or we can find that here in this side. So we're going to use 2 tel. So why 2 tel? There is 1 tel here, 1 tel, 2 tels. So we use 2 tel because a 2 tel test is appropriate if you want to determine if there is a significance difference between the two groups you are comparing. So that is why we are going to use the 2 tel here. So now in 2 tel, as you can see, in 2 tel, we can see the 0.01 here. So this is the 0.01, and then the 14 is in this side. So 14 is in this side. So now let's compare. So let's compare. So that is how we get the 2.97. So that is how we get the 2.977. So our critical value here is 2.977. So now that we have our t value, or the t-test, which is 16.837, and our t value, and our t critical value, which is 2.977. So now we can see that there is a big difference, on the results, which is the t value here is more bigger than the t critical value. So our interpretation is that the computed t value of 10 is 16.837, which is much greater than t critical of 2.977 at degrees of freedom of 14, at t critical of 0.01. So at a percent level of confidence, which is significant. So that is why it is significant. So this means that the general acceptability of the quality attributes of pulveron with and without milkfish bones is really differ from each other, because milkfish bones is more acceptable than pulveron without milkfish bones. So maybe you are confused on how we get this significant here. So on comparing computed and tabular or critical value, we need to consider these two things. So this is the explanations of this. So it is significant if the computed t value CB is equal to or greater than TB, or which is tabular or critical value. So it means if our t value, or the result of our t-test, is greater than the result of critical value, it is significant. Next, it is insignificant if the computed t value is less than the t tabular or critical value. So therefore, it is insignificant if the result of our t-test earlier is less than to the critical value. So that is why we have significant at 0.01. So 0.01, it is our probability value. So that's all, and thank you. I hope you understand.